Position is where you are in relation to a reference point. Okay, if you're talking about a point moving, distance is how far the point moves. The point could move left and then right and then left again. We would want distance is usually referring to total distance, whereas displacement is the shortest distance between the start and the end. Where you end up, the shortest distance between the start and the end. One of the problems you had on that AP packet that you had over the spring break was really a lot of you gave a displacement answer instead of distance answer. Distance can often be greater than displacement. Sometimes they're the same, but they're often, distance will be greater than displacement. Okay, velocity is the rate of change of displacement. It's the rate of change of displacement. It's the derivative of the position function. It could be positive. It could be negative. It could be positive or negative. It does have magnitude and direction. Okay, so if you have vertical motion, positive velocity means you're going up, negative velocity means you're going down. If you have side-to-side motion, positive velocity would mean that you are going right, negative velocity means you're going left, like the number line. Speed is absolute value of velocity. And it's always positive. Okay, speed's always positive. Acceleration is the rate of change of velocity. We've talked about that before. It's the second derivative of position. But acceleration is the rate of change of velocity. It could be positive or negative. Okay. If you have displacement is given by S of t, that's your position function, then velocity is S prime of t. And acceleration is v prime of t, which is equal to s double prime. That's nothing new. We've talked about that before. Surely. Yeah, y'all need to let me know. I can see the s double prime of t. Okay, if you're given acceleration, to find velocity, we take the antiderivative of acceleration. Right? If you're given acceleration and you want velocity, you take the antiderivative of the acceleration. And the antiderivative of velocity is equal to displacement or position. Do they use S of t in physics? Or changes? Not generally? Okay. And it doesn't always have to be S of t. Generally in math classes that means position. But the antiderivative of velocity is the displacement. So and that takes into account negative and positive values. So position, same thing. You know, when we've looked at graphs, we said that looking at the graph, if the area between the curve, the x-axis and the curve is above the x-axis, it's positive distance. Under the x-axis is negative values. So you might be going right and then turning around and going left. Or you might be going up and then suddenly turning and going down. Because a velocity graph is a graph of derivatives or slopes of the position. Okay, absolute value of velocity gives us total distance traveled. So if you want total distance, you always have to use the absolute value, but if you just want position, you take the antiderivative of the velocity. An average velocity can be found in two ways. Either the slope of the secant line through the endpoints of the displacement graph, or position graph, so if you have a position function, you can do S of B minus S of A over B minus A, or average value of the velocity. And average value, remember, is 1 over B minus A from A to B. Okay, T. You got a negative number? Okay, is that possible? It is possible, because if it's going up or down the y-axis and you get a negative number, that means it ends up below the y-axis. So what is that negative number? Good. And this is feet. If the velocity is in feet per second, position is feet. How do we get acceleration? Derivative of what? Acceleration is the derivative of the velocity. So that is that one's nice and easy. So what is acceleration at 3? Well, that only applies to the original function, S of t. -1 feet per second squared, right? Because it's acceleration. Okay, at what time is the particle at rest? When do we know the particle's at rest? Okay, so you're going to have to look at your calculator on this, because that velocity function I don't think we can factor. But AP exam, you need to state, even if you're looking at your calculator, if you're going to get a calculator answer, you need to have something that shows them you knew what you were looking for when the velocity equals 0. So how would we determine when the velocity equals 0? Set what equal to 0? Okay, can you factor it though? That is not, I don't know how to factor that one. It's not a quadratic equation, so what would we do? We could graph the function
And once you graph the function, you find it where the slope will be 0.
Okay, now, where the velocity equals 0.
Yeah.
So what are you looking for on the
Where it
graph?
crosses,
Where the graph equals 0?
Where it crosses the x-axis. Your calculator can show you that.
Graph the velocity and then
Graph the velocity. And then see where it crosses the x-axis. Do that and see what you get. You've got a calculator right there. That's pretty easy.
Well, how do you find x-intercept
An x-intercept, another name for an x-intercept is a 0 of the function.
So when it says calculate,
You can do 0. If it's not something that you can look at easily,
Negative 5. Well, going to find what the light is.
do what?
So shouldn't it
Find where the derivative equals 2, where the velocity equals 0.
Wait, time can be negative?
I got one that equals 1.
1 and change your window to just a, oh, let's do
when y equals 0?
Let me just zoom out.
Yes.
It'd be 4. I
looks
got
like it 1 and
1 and 4.
1 and 4.
What? What?
So when you put it t equals 1 and 4.
Yep.
Oh,
At time equals 1 and time equals 4 seconds. Look at your graph. It's gonna, I think it looks something like this. And this is 1 second, and that's 4 seconds.
When x equals 0.1.
Yeah, that'll work. Then you have to take the absolute, be sure you got the absolute value. Okay, so we okay so far? Okay. Velocity from 0 to 5 seconds. That's 1 over 5 minus 0. From 0 to 5 of the velocity, which is really s of 5 minus s of 0 over 5. So if you have your position function in your calculator, if you put that in there on number 1, you can use that for s of 5 and s of 0 over 5.
That's so nice.
So notice these two statements mean the same thing. This is average rate of change of position. This is also average velocity.
I like this better than the other stuff.
All right, so here you should get approximately some number.
1.3.
Did you divide it by 5? You should get a 0.083.
How do you put in y1 on the regular screen?
Variables, y variables, function, y1.
I don't have S on here.
Okay, if you don't have s on there, then
You get the different number.
okay. Okay, so in order to find the minimum velocity and the maximum velocity, we had to set the acceleration, find critical numbers by setting acceleration equal to 0. Because this was a closed interval, we check endpoints, values of the velocity at the endpoints and the critical numbers. Okay, and it makes sense that we said the only place by looking at where it's increasing and decreasing we can have a minimum was when time is 4. But we found out what that value was in the velocity function. We want to know on 8, how far did the particle travel from time equals 0 to time equals 5?
Do you want distance or displacement?
So that's,
How far did it travel? Is that distance or displacement?
Distance.
It's distance. So this you can use your calculator here, but what you need to show is from 0 to 5. Hopefully by now you've already got your velocity function in your calculator. You'd need to put this on your paper.
does that say DT?
dt, yes. V of t, the absolute value of velocity times dt.
Does that say 0 to what?
0 to 5, because we're going from time equals 0 to time equals 5. So you've got this velocity function in your calculator, right?
No.
No?
Yes.
Deleted it.
He doesn't.
Well, you shouldn't have.
I know.
All right, so you've got that. Say you have it in Y1 on your home screen. You want to put the absolute, well, your calculators are different. You can do Math 9.
Can you absolute value it afterwards?
No, because it won't have.
Okay. How do you insert
Okay, so
that?
you're going to have Math 9. Let me see if I can pull this up.
Put it in there.
You can't just put it in there.
Put it in there.
Oh, you can go like in between. Yeah, here you can go math
Put it
and
in,
then
put it
do
in.
absolute value.
Plugging into our calculator here, we got 4.917. This one is just from 0 to 5, which you need to show this on your paper. Even though your calculator's doing the work, you need to have this integral shown. And that was approximately what? 0.417 feet. Bless you.